Hi everyone. Today I wanted to show you how to simulate programs related to Cortex M4 based microcontroller, which is TIVA C series mainly, TM4C123GH6PM. This is a widely used microcontroller. How to simulate programs using Keil software, that I will show you. So there's the Keil microvision. Just double click on that. So it will open that IDE. Okay. So here, go to project, new microvision project, and you create your own folder. Wherever you want. So in F folder, I want to create with some name of your folder, your interest. I'm taking a name as ARM Cortex M4 and give a project name. So consider project 1. And now here you have to select the target, of course. The target is TM4C123GH6PM. Okay, this is the microcontroller which I am aiming for. Click on OK. And now it is asking you whether to copy the startup file to your project or not. So here you have to decide in which language. If it is in assembly level language, you no need to add the startup file to your project. You can click on no. If you want to work with high level language, C programming, then you have to add the startup file. Click on S. So now my file I am supposed to be using C. So click on S. So there's the startup file that you can add, right? And now you can take a new file. So there's the main file that you are adding to your project. Okay. So save this file. Of course, it's empty file. After that, we will write. So a simple LED blinking we are using with extension .c. And this file will be saved in the same folder that you have created. You add that file to that project. Right click on the source group, add existing files, select this file. Okay, so this is selected. There's the file. Here we will write the file. Basic LED blinking I'm writing here. Okay, so the simple file related to LED blinking. So TM4C123GH6PMH is the header file, which includes all the register names and all. So while writing there's a code, you need to assure that this header file should be there in the given folder, using folder. Okay, so if it is not there, these registers are unknown to the compiler. It shows you error. Okay, so you have to copy this header file, which is available in the internet, or else in the bin folder whenever you install TIVA C series software, you will be getting this header file. Okay, or else it is even available in the internet. You just copy that. I have already no, so I'm just copying that header file to the new folder that I have created. Okay. So you just copy this and paste in your folder wherever you are working. Okay, this is mandatory. Okay. So then you just blink, compile it, will gives you no errors and no warning. So let me explain this program, which is very clear. We are taking just port F, red LED. We will see the TM4 diagram architecture in the next video. Just a simple program. I wish to show you how to simulate the program. Okay. So before this, you need to do few adjustment, which is nothing but configuring flash tools. And this is the device tab, which target you are selecting. And next in the target tab, you should make FPU as not used. Right now we are not using. And remaining everything is same. And finally in the debug tab, we wanted to use the simulator. So click on this radio button. And the parameter that you have to pass is hyphen small t LAUN launch pad DLL. This you have to extend, then click on OK. Right? Now compile the code, build the code. Okay, you have received 0 errors, 0 warnings. Okay, build, rebuild all. Now for simulations, you can go to start at stop debug session. Of course, it is evaluation mode. Click on OK. Then you will be entering into debug window, disassembly window here, and this is your program, and these are the registers, right? Okay. So here are available options for burst execution, and this is for single step execution. Whichever you want, you can do that. I'm going with the burst execution here. So it's executing, actually the program is executing what you are expecting. You are expecting this red LED, which is connected to port F.1 pin, have to be alternatively on and off with a delay of specified count. Okay, so you want to observe the changes. If you have hardware, you can observe, but simulations virtually you can observe that here we have a peripherals. Okay, so here the Texas port F is, click on that. See, my PF1 to which where my red LED is connected, it's blinking. There's one way. The other way, you can even observe it in the form of a waveform by using logic analyzer. Click on this logic analyzer and set up the pin. Click on setup and select add pin. Here you have to use capitals. Port F.1 is the pin that we are aiming to observe. Click on that. And since it is a bit, it's not a 32-bit number, it is not in analog, we want it to be bit. Change it to bit and then close. So see, my waveform is fluctuating, varying between 0 and 1. Okay, so you just zoom in and zoom out. Okay, so this is how you can even observe. So if you want to observe the time delay exactly, you can stop the debug session by clicking here red button. And by using the cursor and the mouse positions, this is the cursor position and this is the mouse position. So the difference is given here as a mouse position 35.37701 second. Reference point is 35.34562 seconds. The delta, the difference of your off time duration is exactly 31 milliseconds. Similarly, if you want to calculate on time duration only, then you can use this. Like this also, you can calculate the on time and off time durations. Okay, this is how the simulations you can even do on a Cortex M4 processor, which most of we don't know. I have searched several videos on YouTube. I found this from John Volcano, where they have provided, which is Texas installation, University of Texas at Austin. I am referring this textbook also even for the information. So if you click on here, we'll be getting a website. Here we have the software called Texas .install softwares. They have developed a DLL extension for simulation purpose. Okay, so this Texas.install is developed by them. So which is very useful, where without hardware, we can even work at your places. Okay, so this is the software which is available in this website. This is what we call Texas install.exe file. You can download that, install that and do the settings in the debug window. You can work out on the simulations. Okay, so that's all for in this video. Thank you.